Hi everyone, in today's lesson from Unit 7, Notes number 3, we'll be taking a look at the special right triangles. Well, there are actually two different special right triangles. In today's lesson, we'll take a look at what's called the 45-45-90 or 45-45 right triangle. If you take a look at that triangle ABC, notice that I've given you a measure of angle A of 45 degrees. So if angle A is 45, take a second and solve for the measure of angle B. Right, remember that in a triangle we have 180 degrees, so we can subtract 90 and then subtract 45. Those are the two angles we know the measures of already. And when you do that, you're left with 45 degrees for angle B. So what we notice about angle A and angle B is that they are congruent. They're both 45 degrees. And that makes this triangle isosceles. Because if two angles are congruent, then the sides across from those angles must be congruent. So those are the two legs in our right triangle. And they're congruent to each other. Alright, the third side, again, is our hypotenuse because it is a right triangle. Since triangle ABC is an isosceles triangle, what do you know about the sides of the triangle? We can say they are congruent for sure. Okay, next we're going to investigate the relationship between the lengths of the legs of the triangle and the hypotenuse. So it says to assume that line segment AC is equal to 1. If AC is equal to 1, then we know that BC is equal to 1. And then we'll have to solve for C, the hypotenuse. So we're going to do 1 squared plus 1 squared and set it equal to C squared. 1 squared is equal to 1, so we'll end up with 1 plus 1 here, which is 2. And then we have C squared is equal to 2. So next, take the square root of both sides. And the square root of C squared will give us C, but the square root of 2 can't be rationalized. So in our triangle, the sides are 1, 1, and the hypotenuse is equal to the square root of 2. Okay, so to answer the question, BC be equal to 1, and AB was equal to the square root of 2. Okay, next we're going to try two more triangles. So in the triangle on the left, notice that this leg is given to us as 2. So this leg must also be 2, and we're going to solve for that hypotenuse. So in the Pythagorean theorem, it'll be C squared is equal to 2 squared plus 2 squared. So C squared is equal to 4 plus 4, or a total of 8 on that side. Next, take the square root of both sides. Square root of C squared gives us C. Sorry, I almost wrote C squared. And then the square root of 8 we have to simplify. So let's factor it into 4 times 2. So C is equal to 2 square root of 2. Okay, we have one more example. In this one, we're given a hint that this is 45 degrees. That means that this angle also has to be 45 because we have a total of 180 for the whole triangle. So that does mean that it's isosceles. So these two sides are equal to each other and they're both equal to 5. Label the hypotenuse as C and set it up in Pythagorean theorem. C squared equals 5 squared plus 5 squared. So C squared would be equal to 25 plus 25. C squared is equal to 50. And then take the square root of both sides. Okay, 50 factors into 25 times 2 since we're going to simplify the radical. And the square root of 25 gives us 5 out in front with 2 inside the radical. Okay, my hope is that at this point you notice a pattern here. Like on the last one, our lengths were 2 and 2, and the hypotenuse was 2 square root of 2. On this one, the lengths were 5 and 5, and the hypotenuse was 5 square root of 2. Up above on the very first one we did, the lengths were 1, 1, and the hypotenuse was square root of 2, which you could also say is 1 square root of 2. So think about what pattern you notice there. And hopefully you notice that you multiply the length by the square root of 2 to find the hypotenuse. So for example, just really quick, we had a 45, 45, 90, or we just called an isosceles right triangle. If I told you that each leg was equal to 27, we'd have 27, 27, and then 27 square root of 2 for the hypotenuse. So in general, the relationship for the sides in a 45, 45 right triangle goes like this. The two lengths are equal to each other, and we can just use x to represent them. So it'll be x and x, and then the hypotenuse is always going to be the square root of 2 times the leg. So it'll be x squared root of 2. So it'll go x, x, x squared root of 2. Alright, so you can use this to quickly solve for the missing sides in a 45, 45 right triangle. For example, in number 1, again it's 45 degrees, so this angle is 45, so it's an isosceles right triangle. So that means that the two legs are equal, so we've got 3 and 3, and then our hypotenuse would be the leg times the square root of 2. So keep in mind that this is x and x, and the hypotenuse then was x squared root of 2. Right, on the next one, it's a little tricky because we see a square root of 3 here, so that's our x. But again, it's a 45, 45, 90, so the two legs are equal. So this will also be x, which is the square root of 3. And then the hypotenuse will be x square root of 2. Well, we're going to take and plug in the square root of 3 for x, and multiply it by the square root of 2, and we end up with the square root of 6. For this longest side in this right triangle. Okay, sometimes they do get a little bit tricky. These two aren't too bad. Come in and mark these two sides equal to each other and give them each an x, and then label that hypotenuse as x squared root of 2. So you may be able to see it on some problems. Like you may be able to see what x is equal to. But if you don't see it right away, what you want to do is actually solve for x. So to get rid of the square root of 2, we will divide both sides by the square root of 2. Here and here, they divide out, and that leaves us with x equals 10. So the two legs have to be 10. So we've got 10, 10, 10 square root of 2. Remember, to go from the leg to the hypotenuse, you multiply by the square root of 2. Right, in number 4, our two legs are equal to each other, give them each an x. And then the hypotenuse is found by taking the leg times the square root of 2. So think about that little equation. The square root of 8 equals x squared root of 2. And divide both sides by the square root of 2. So we've got x. And then square root of 8 divided by the square root of 2 would give us the square root of 4. And then that, my friends, is just 2. So we have 2 and 2 for the legs. And you say, well, it doesn't say 2 square root of 2, but the square root of 8 simplifies into the square root of 4 times 2. So there it is, 2 square root of 2. Final answer. Alright, good luck on the homework. Make sure you speak up and see me for extra help if you are lost.